Good morning. Today we are learning about the quadratic formula, which is this monster of a formula right here. It looks very daunting. However, all it does is it solves quadratic equations, meaning it gives you the solutions or the x-intercepts. Now you might be saying, Miss Jeter, we can just graph it and get the x-intercepts from the graph. However, we have been running into an issue recently where one of the x-intercepts is a crazy decimal, which cannot be converted into a fraction. Now that's where the quadratic formula comes in. For the purpose of this video, I'm going to kind of go through it quickly and throw in like a calculator trick you can use. However, I am going to be showing y'all how to use Desmos in order to get these irrational decimal solutions. To start off, when trying to get x-intercepts, we always have to make sure that the equation is equal to 0, and we want to see that it's written in standard form. Looking at this example, it is equal to 0, and it is in standard form because the exponents are going from largest down to the smallest. So next, we are going to identify our a, b, and c values. A is equal to 1, b is equal to -5, c is equal to -36. Your last step is to substitute these values into the formula and simplify. Substitute just means replaced. So anytime you see an a in the quadratic formula, we would be replacing it with 1. Anytime you see a b, we will replace it with -5. Lastly, the c is going to turn into a -36. So the last thing you have to be careful of is this symbol. This is the plus or minus symbol, meaning you're going to have to do this twice, once with a plus, once with a minus. So let's start off by saying x is equal to, or the x-intercept is equal to, negative b, which is -5, plus, let's start off with the plus, the square root of b squared minus 4ac, all divided by 2a. Now right now we can just go ahead and type it in the calculator, and this one will give you a normal number, just a perfectly regular number, no need to stress. Da, 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 da. We're just going to double check that we typed it properly. That looks good. Enter. Voila! Your x-intercept is 9. Congratulations. But now we have to do it all over again. But the only change will be instead of a plus, we are going to use a minus. What's nice about this is you already typed it in the calculator. So all you have to do is copy and paste, change the plus to a minus, and you're done. Copy, paste, change the plus to a minus. There you go. Your other x-intercept is -4. A shortcut would be, hey, we're going to replace our a using the funny equal sign with the values we found from the equation. A was 1, b was -5, c was -36, and then you would just type the quadratic equation, quadratic formula, the way it was provided to you. -b plus square root of b squared minus 4ac. Oh, remember to put times between your variables when putting them in the calculator. So all I did right now is label a, b, and c with a funny equal sign, or the store value sign, and then I typed in the original quadratic formula. And I got 9, which was one of the solutions we already found. And if I replace the plus with a minus, typing it in all over again, I get -4. So we get the same answer regardless of how you do it, but sometimes we will get really strange, irrational solutions. And I'm not going to spend my time talking about this one because a lot of math goes into it. Instead, I'm going to jump right into showing you how we could bring our answer to the closest possible scenario. So starting off, we want to label our A, B, and C values. A is equal to 2, B is equal to -3, C is equal to -5. And we are going to write our quadratic formula like so. Negative B plus or minus, since our answer choices have plus or minus, the square root of -3 squared minus 4ac divided by 2a. Now, here's what we're going to do. Since our answers are multiple choice, we are just going to simplify this as best as possible. Negative times -3 is +3 plus or minus. Now the square root, what's nice is you can just type everything inside of the square root like so to turn it into like a normal number. So everything that was under the radical, I just typed in, and that turned into 49. 49, all divided by 2 times 2, which is 4. So here we can see our answer is our second option. So sometimes that's what the STAR exam is asking you for. It has a really, really weird solution. Now, what you could do is go to Desmos. Let's go ahead and share our screen. And we are going to type in the original quadratic formula. Actually, let's just do this. Let's type in the original equation. This way you don't even have to set up the quadratic formula. And remember, if I put equals 0, it doesn't work. So never type equals 0. And now we know our x-intercepts are -1 and 2.5. So if we typed in the answer we got correct, it's 3 plus square root of 49 divided by 4, which is the 2.5 value. And then if you typed it in again with the minus, you would get the other x-intercept. So this is how you can do it without knowing the quadratic formula at all. However, it really is just substituting the values and simplifying it as much as possible. So let's go ahead and do this one just using Desmos. We are going to type in the original problem. Our x-intercepts are 0.6 and -1. And now we have to type our answer choices until we get -1 and 0.6. So let's write those down. We need -1, 0.6. So starting off with the first option, -1 plus the square root of 11 divided by 4. That gives me this mess. Now let's just try switching it out with a minus. No, that is not going to be our answer. Now let's type in option 2. -2 plus the square root of 64. That is 0.6. That we like. So that has 0.6, but does it have the other value we need? Well, to check, you just switch this out with a minus. That has the -1, so this is our answer. Now, if we go to the back, we just follow the same procedure. X squared minus 4x minus 3. Our x-intercepts are -0.646 and 4.646. Now we have to type in our answer choices until we get one of these. Well, the first one is out, so it's not that one. The second one, that looks kind of close, 4.64. So let's try this one with a minus. -0.64. That would be our answer. Here they're just rounding. They just rounded it. So this is how you do these problems. Most of the time your answers will have a radical in it. That's how you know you're going to have to put it in Desmos to convert it into a decimal. So that is it for the quadratic formula. It does come up in SAT, ACT, maybe the TSI. So learning how to do it by hand wouldn't be a bad idea. But for the sake of the STAR exam, we are going to be focusing on just finding our answers through simplifying it, not completely solving it.